Hello and welcome to another free code session. My name is Jason Bach and I'm going to continue on with partially applied. And as I was thinking about what I want to do in this episode and just reviewing that in my head, I realized I don't know if I'm actually ever going to get to testing this out for another couple of episodes because there's all the grunt work and all the stuff you have to do to start off with. And that's what I'm going to be doing here. The main thing in my head is to go, what I really want to do is analyze what all the receivers have found and then make sure I'm creating the right diagnostics, and that if I don't have diagnostics, and actually have a way to generate all of the code that needs to be done, and kind of do that in one class and let that handle it, I think. So what was I going to call that? I just had a thought in my head. I was going to call that the applied analyzer. Well, it's not an analyzer. It's not an analyzer like the .NET analyzers are, but it's a way to say receiver analyzer. So again, naming. What is important in coding? Naming. Naming matters. We have a generator, we have a receiver, and we want to have because if I go look at rocks here, we have a generate mapping, but that just does this, and then it goes off here and says, now build it. So we'd want a builder. See, builder, partially applied builder. So we're going to want a partially applied information, which tells you all the things you're going to need to know. And then we're going to want a partially applied builder. So let's do that. Let's just put the classes here first. Partially applied builder. Well, yeah, that's one of them we're going to need. And then we're going to also need a partially applied information. Okay, this is the one that's a little bit more important to start off with. Public seal class. Okay, and then what we want to take here is a public, and then what is it? The list of invocation expression syntaxes. Okay. Candidates. And what we what we're going to want to do is say this dot candidates is equal to candidates, and we're just going to do a read-only property. No, we want a read-only field. Thank you. Except we don't want to call it that. Okay. And then what do I do in rocks with the mock information thingy stuff? Yeah, I do validate. Okay, so we're going to do the same thing. This dot validate. All right, so private void validate. No, that. And we're going to want an immutable array of diagnostics because we want to know if anything went wrong, because things can and do and will, as much as I wish they wouldn't, they do. Okay, so here's where we're going to want to say for each var candidate in this dot candidates. Now, this is, if I go to this one, this is where I'm going to want to say that's the invocation. Okay, but now we want to look at the arguments list and find the method symbol. Okay. So we're going to do this. Var delegate argument is equal to candidate if, well, okay. We've been looking for functions or calls to partially.apply. We don't even look at the arguments. So here we're going to have to say that you have to have at least one argument. If candidate.argument_list.arguments.length count is equal to if it's less than, okay, well, you can't have one. You have to have at least two. So if it's less than two, then we're going to diagnostic. Okay. Else we move on. Okay. And we're just going to look at the first one. Now get method symbol. This is something that we want to say try get method symbol. Yeah. So we want an expression syntax extension method. And again, this is an experimental thing, so I'm just going to leave things kind of public unless I have a really good reason not to. So we're going to, no, not there. We're going to want to apply this. Okay, and do that. So we're going to say add missing usings. This self. Oh, no. Then we have to pass in the model as well. So that takes care of all that. Okay. So we're going to do here that. Now we need to say no, partially applied. That should do get method symbol. Oh, we need public static that. That should now work there. Now we just need the model, so we need to pass that in as well. Semantic model. So we're going to say this candidates, this dot model is equal to candidates model. What do I need? I need a read-only field. I wish it would do a better job of inferring there. Semantic model. Okay. So now we have, did we actually get a method symbol? Okay. If delegate symbol is null, then diagnostic use the toString. Okay, because you want to basically say, hey, I tried to do it here. I couldn't figure out what this was as a method call. Okay. I think I wanted to call this try get method symbol because we may not get it. So now here's the second step. Else if was found is kind of a bad wording. The thing I just spent like 10 seconds or 20 seconds on is debating what am I actually returning here? What I'm trying to return here is saying, hey, if we got the symbol information because the call to partially apply was fine, then the first thing happens here. It's the second one where we're trying to say, well, it couldn't actually find an overloaded resolution to partially apply to match this, but the candidate symbol is there, so we found it, but that's the actual thing we're trying to do, which is in the case where it worked, which is when it's true, we don't want to use it because it's already been done. It's only in the case where it is false that we care. We actually want to get something back, but but it's not a problem if it's true. Else if it wasn't found, okay, then we're good. This is what we are looking for. Okay. Now in this case, this means I have a function like maths.add a and b. So now what I need to do is, and this is where it gets a little dicey, is because I don't want to generate delegates for things that I've already done. Okay. If this wasn't bound, it means that I definitely need a function, a delegate type to match that first parameter. Okay. So that's definitely a given. And how do I do that? Not only do I need, but yeah, here's the thing though, is that I need to also look and see, is it, because it's possible that you generated the delegate, because here's the thought. What I'm trying to eliminate is that I need a static hash sets to say, have I actually generated this or not? I really, 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 really want to avoid that. And so that's what I'm debating in my head right now is, do I actually need that? And this is where I think the case came in that I was doing here, which was if the fifth pass comes through, then what would happen here? It wouldn't work. I think in all cases, if I couldn't find an overload, it just means that whatever got passed in, it couldn't match to. And so you need to generate both of them. Though it is possible, that's the other thing I think I realized up here. That's why I did the third pass here. It is possible that you do this, and this is okay though, because you're saying that's fine. You're saying that that's okay. I don't need to generate another one. That because the type this would match. I had one argument here of an int, and that's all I care about. Again, where it comes from doesn't matter. So what am I doing on the fourth pass here? The fourth pass is just like the third pass. What's the difference? I have no freaking clue. That's fourth is the same as the third in that case. In the fifth case here would now go, oh, well, you're trying to do a sum, that's 4. I obviously couldn't bind to that, or find a resolution to that, so that's an error. So now I have to do that. I need to create a delegate that returns 3 because I have 1 here, so I need the one that has the 3 there. I think this might actually work better than I expected, which is I only say when I didn't find it, this is exactly what I'm looking for. Okay. So that actually helps a lot, which is I narrow down all the candidates that I could possibly have, though I need to do one other thing. Okay. So in this delegate symbol, the other thing I need to do is say if delegate symbol dot parameters dot length. So let's say I did the sum, which was, or let's just do multiply because it doesn't matter. That's 2. And I passed in 1. That's okay. But if, so the number of parameters there has to be strictly less than, no, wait a minute. If I had 2 there, you're like, what are you talking about, Jason? What I'm getting at is here I have 2, okay? But what I'm really passing in is 1 to a function that can take 2 arguments, okay? So 2 here is okay. If I did a sum here, so I have 2 here and the total number of arguments is 4, that's okay. If I had 4 arguments here, that's okay, but I cannot be greater than the number of arguments I'm passing in. Yeah, the number of arguments I'm passing it into the candidate. Argument list dot arguments dot length or count, whatever it is. If that's greater than the number of parameters that I know are in the delegate symbol, that is also a diagnostic. Okay. So this is a diagnostic. We're passing in too many parameters to the target function. Okay. It could be more. It could be where it fully applies that it doesn't matter. We've done too many. Okay. The apply function needs the target function and at least one partial, or at least one parameter to partially apply. Okay. There's another case here too, which we don't even want to do this. If you give me less than 2, if you gave me less than 2, we need the target function at least 1 of 5. So if you gave me 2 or more, I'm good. Then I can do that. If I know that's bad, because then I couldn't find anything at all. If I couldn't find it, then this is what we're looking for. But now we have to say, did you do the right? So this is too many counts. Now we actually have to say, and this might be the fun one, else if the types. So now we want to look and say, well, I expected that the type on the arguments list is, I want to make sure that I have the right types of things. So I want to look at each argument and say, what is your symbol? And if it doesn't match the parameter symbol, then we want to match each argument type to the parameter types. And okay. So we're going to say for var I is equal to 1, because we want to start at the first one. I less than candidate argument. You know what? We want to just grab the arguments. Okay. Yeah, that's fine. Okay. Arguments, length, count, I plus plus. Okay, now it gets a little tricky because we only have syntax here. We need type symbol. Okay, so what we're going to do is say here that var symbol is equal to some model that get symbol of argument is equal to arguments of I, and then say, do we want to do a try get symbol here? Because I believe it would be the same thing that we ran into before, which is, yeah, I'd almost think that this is going to be a guessing game here. But I almost think that this would be like what we're seeing with the try, which we know we're not going to be overloading. So we're going to want to look at the candidate symbols. Actually, you know what? I don't have to guess. I can come here, and which one would do this? I think it's the first one. Because the first one, we don't have anything at all. And so could we determine what analyze code? Let's come down there. And we can, yeah, so we can do this. This I know. Okay. But what I'm curious about are what you get for symbols on the passed arguments. Okay. Why are you taking like forever and a day? You really, really shouldn't. Okay. So we're going to clear this out, and we're going to say model.get symbol info for apply invocation argument list arguments of 1. And you don't know anything about that. Well, that sucks. Apply invocation. Oh, I know why. It's not the argument. You need the expression. Still nothing. And there's no candidate symbols either. Well, this is a whole boatload of failure. This is going to suck. Well, you know what that is, right? That's, yeah, it's a literal expression syntax with a numeric literal expression. Yeah, but that's not really what we want. Speculative? Yeah, we don't. That's where you need a location of something. And that, yeah, I didn't think about this too well. Yeah, you don't know what the declared symbol is either. It's a 3. Yeah, that's all it is, because it's just going to be that. But what is that? I mean, I can look at it and go, I know what that is. That is actually what I want is its type is literal L. Well, it should say true. Okay, so now what we want to do is L. No, as. And then the token, kind, get location. Show. Yeah. Raw kind, syntax, span star, blah, blah, blah. Yeah, I want you to tell me what that actually is. I want you to tell me that it's like, what is this? And unfortunately, I don't know. I mean, I know, yeah, here I can say I know it's an int and that's an int, but what I needed to do is say, what you're giving me, you could have passed me in gwid.newgwid for all I know. I have no idea. Well, I do, but what is the thing that you're passing into me? And if I can't figure that out, then I kind of would have to just assume that what you're giving me is correct. And if it's not, well, then you go fix that, you know, which as an experiment for an MVP, I'm going to invoke the MVP, the minimal viable product, which is what I could do is just say, well, you pass me in an argument or arguments. Okay. I don't really know if those match or not. And if they don't, if they do or they don't, I don't know. So what I'm going to do is say, well, like in the case of sum, where I had 4 arguments, 4 parameters for sum, if you're going to give me 1, then I need to, first of all, generate a delegate that matches the sum function, SUM, not SOME, and then a delegate that matches the function with the last 3 parameters, which I know what those are. Like if I go here and I start going into this, you're going to see, aha, it's name of A and its type is int32. Okay, and it's a type of int. The point is I have the types information here. So what I could do is just say, I'm going to generate it. But then if there's still errors, you're going to see that it can't bind that to that. And that would suck. What I'd really like to know is right away, do you, can you, will you, should you pass in a value that is actually correct? And I really don't want to, I want to do this where I'm like partially, you don't know what that is, apply 3. Okay. Well, now if I look at the syntax visualizer and I see this, it's going to go, well, yeah, I don't know what that is. But you have an argument here, and it's a numerical literal expression. Okay. Its raw kind is 87. Yeah, it's a numerical literal expression, but I want to get the type of these things. And what happens if I did like this? Well, now it's going to say it's a string literal expression, okay? And its raw kind is something else. Those are enumeration values. I don't know what 8750 is off the top of my head. Though I'm kind of curious if I come back down here and I say delegate argument, not delicate, raw kind. Raw kind is an int. Kind is equal to. Well, wait a minute. Why wouldn't it show up here what the kind is? Why are you just showing me kind? Oh, that it's a string literal to. Okay, it does. I was just being stupid. Okay, that's fine. So we can say literal. So you can have a character literal, a default literal, a false, a null, a numeric, a string, all that stuff. XML literal, which I really like. I'd only care about true and false, string, literal. Is that an expression or a token? It's a token. If I did 3, that'd be a token. Okay. 0.2, that would also be a token. False, that would be a false keyword. So I guess one thing I could do is just say for all the literal tokens, you know, that I know of, numerical, string, and Boolean, then I would just say, well, yes and no, because if you notice for the 3.2, it's numerical. What I'd have to do then is take the value and, where was I getting value from? Almost at time anyway. Argument, numerical. I'm almost positive I saw like a value thing here. Yeah, now it's value of 3 if I do 3.2. It's still 3.2. If I do this, it now has a value because they're literal expressions. So if it's a literal expression, then I could just, oh. So if I say expression, this is just playing, experimenting a code. I got a point on this one. As literal expression syntax dot value. Really? Come on. String literal token. That's the expression. And then we want what? The token? Dot token dot value. And that is just an object. But could I actually look at the object and say, is the type of that object, and I get that's the type in system reflection land. What I want is then to match it to the type that I see there. And if those two types are the same, then that would work. Now that's just for literal expressions. What happens if I'm not passing in a literal expression? Like if I do gwid.newGwid, that's a, or if I pass in an A, where A is equal to new customer. How would I know that? You know, this is something that I actually went through when I was looking at building this, which was what happens if somebody passes me an A as the first argument? How would I know what that delegate type actually is? I have no idea. I don't know what A is actually referring to. So I think what I might have to do here is, for an MVP, for right now, I think what I'm going to do is just say, you know what, if I see that the right number of arguments is for the parameters, like I have at least one, but not, oh, that's the other thing. Oh, I'm glad I just realized that too. Okay, so what I also need to do here is say, if I come back over here, what I also need to say here is, so I get, if it wasn't found, okay, but what you need on the delegate function is if delegate symbol parameters dot length is less than 2 as well. This is a diagnostic, okay? Diagnostic. You need at least 2 parameters on the target function to do partial application. Because in the first case, I was pointing up to this thing. This is the first case we're saying, I don't know yet what you've actually passed in. I need at least something that I think is the first thing, that's the function I'm going to try to partially apply, and then at least 1 argument. Okay. Now I'm saying I found what the function was, but that function only declares 1 argument or 0. Then this is worthless. Then you can't do that. So this is a different less than 2 kind of case. Okay. Then we want to say else here. I don't like all the is's, if's, else's. Okay. And here's where I don't really want to match. Okay. Else. This is what we are looking for. Okay. I'm going to just assume that whatever you pass me in is going to work. And if it doesn't, well, then you're just going to get a compiler error. C# will kick in and go, well, I thought I was supposed to create a apply function that takes a delegate of a specific type as the first argument, and then 3 arguments that are all ints. But what you actually passed me in are an int, string, and GUID. Well, too bad. This is what the function is that you actually gave me. That's the thing that's golden. So I'm just going to, build off of that. I know you gave me 3, so I'm going to assume you're doing the right thing. But if you're not, then, oh well, it's not correct. This is something that's giving me the willies, because do you end up getting into some kind of circular case where you keep trying to generate this and it would just keep saying, no, this is wrong. Where what you're generating doesn't match. But I think that would then be on the onus of the person actually writing the code. I don't know that for certain. This does give me some, it doesn't give me great feelings, but I don't know off the top of my head how to actually figure out what, in a very clean way, what the types are for the expressions there. If there is, then yes, I can do this. So what I'm going to put here is to do, it would be highly desirable to know what the types are of the arguments, so we don't even try to generate anything. But for now, I can't figure that out. Need to revisit. Okay, so it's a to-do. I know I need to come back to this. In fact, all these are technically to-dos. Let's get those in there because I need to put the diagnostics in, which I'm going to copy from Rocks and do the same thing. Okay, and I might do off camera a lookup and say, hey, if I have I'm trying to call a function and I'm passing in an int, a string, and then this. See, that's the thing though. What is a? Like if I just gave you an a, which isn't a variable, what really is that? And the thing I was getting at is there's a helper library, Roslyn Utilities, that apparently can give you some analysis to figure out, given what's passed into you, what is actually it. And again, for the cases for like literal expressions, I think I could do something that's reasonable and figure that out. For things that I really don't know what you're going to be passing in, I don't know. So I don't, though this may never be something I can really do? I would always need to know, given these arguments, what actually are they? And if I can't figure out what they actually are, then, because I want the most specific thing. What was if you have like a person, and in one case, A would be a customer, and in the other case, A would be an employee. Well, you could say, I guess, that as long as they're both of a customer type, like what really is the type of A? Because it should know that by the time you're calling there. So maybe I'm going to take that off. I mean, I would hope to say that if you're passing in a variable, it has to have a type. And even if it's just customer, I can generate a delegate that would have that as a customer as one of its parameters. And then in one case, if it's a actual employee, and the other one, if it's a this. The only thing I don't like about that, though, is that then I don't, if you actually want to, if I was really trying to pass in a customer to a function that took a person, would that work with conversions? Tune in next time. I just melted my brain for a second. So I don't think I'm going to be able to figure this out right now, though I'm going to try. And the thing, though, is the case of what happens if it thinks that A is a customer, but in one case it actually got assigned in all the code above it. It got assigned to person. But what got assigned above it was a customer, and in this case was a employee. And the function is actually typed to take an employee, but the delegate's going to be a customer. I think that it actually would be allowed to pass in as a delegate, and then you could pass in the custom type because the base type is customer. And again, we don't care what the actual function does, just that the delegate matches. So I think that would work. So as long as I could figure out what all the types are, the things that are being passed in, then I could do this. But that might take some more work. And I think in the next episode, unless I can figure it out, I'm just going to move on and do these things and just, MVP it and say we'd have to come back and do this. So I'm already well over time on this one. So I'm going to stop for now. And we'll, in the next episode, try to do more stuff. Again, this is more work than I thought, but that's what it takes. That's what happens. So thank you all for watching. Leave comments and questions below. See you in the next episode.